2015 AP Physics 1, question number 4. I think it's the last one. Two identical spheres are released from the device at t equals 0, okay? It's a device here. One is dropped, I guess. One is thrown forward. Height above h, okay. Sphere A has no initial velocity, so this is free fall. Sphere B is given initial horizontal velocity, okay, so you have V initial extraction. And it goes distance t before it reaches the ground. The sphere, are they same mass? Okay, it's two identical spheres, so they have same mass. And they end up at the ground, I guess, at TF, even though sphere B has more distance cover landing, okay, they're at the same time. That's obvious because their vertical displacement is equal and their initial velocity of y-axis will be 0. So it's going to take same time. So at t equals tf over 2, so it's like halfway, so somewhere, halfway is actually somewhere here, I think. No, it has to be above here, right? Above halfway. And halfway here will be actually there, which is exactly in the middle. Right? Actually, that's a good point, because halfway there will be actually exactly in the middle. And that will be the same height here. All right, now draw free body diagram. So the only thing they have is mg, so I'll just write mg here. That was it. So you can say force of gravity, force of gravity. Then what? On the axis below, sketch and label graph horizontal component of the velocity of sphere A and sphere B. So you're looking for Vx, okay? And remember, Vx never changed for both of them because acceleration in x direction is 0. Remember, you only have acceleration y direction, which is downward g. Right? So for sphere A, this was just free fall, right? So sphere A was just free fall. So there's no horizontal velocity in this case. So for A, goes like that. For B, it will be constant, right? So it'll be so that's B, that's I'll use this as A. In a clear current paragraph length, explain why the sphere reached the ground at the same time, even though they traveled this different distance. With reference to part A and part B. What was part A and part B? Part A is free body diagram. Part B is the graph, right? Okay. So how do I explain this? Because H initial is same, right? And H final is basically ground, is same for both of them. So basically displacement in y direction is same, right? And velocity on y direction initial was both 0. Okay? And acceleration in y direction initial is g meter per second, 9.8. Or you can say just write g or 9.8 meter per second square. I'll just call this acceleration y. Then displacement is what? v1t plus half at squared. But both of them give you h as the displacement. Initial velocity is 0, half gt squared. So time it takes will be same for both of them. And if you want to really calculate, the time will be 2h multiplied by 2 divided by g, take square root. So they'll take same time. Okay? So Vx is not going to change the time to fall in this case, right? Okay. Oh, that was it. All right. That's for 2015 free response. Okay. Thank you. Bye-bye.